Hi guys, my name is Minhajuddin Ansari and you're watching the second tutorial on C programming, and today we will be talking about primary data types. So before we talk about primary data types, let me define variables. So variables are storage spaces inside the main memory that can store values, and the type of value a variable stores depends on its data type. So in the C language there are 5 types of data types and they're called primary data types. They are integer, character, float, double, and void. And in this video, we will be talking about the first 4 types of primary data types. And I will talk about void later on in my videos. So right here, I've defined a variable named num, and it is of type integer, so it can hold on to integer values. And in this case, I've initialized it to the integer value 8. Here I've defined my character variable named ch. It is of type character, so it can store character values. So I've initialized it to the character a. Here I've defined my variable named fo. It is of type float, and float data type can hold on to decimal point numbers. So I've initialized it to the decimal point 0.5. And finally, my final variable is named lofo. It is of type double. And I've also initialized it to the decimal point number 0.5. And the difference between the double and float data type is that double data type can hold on to larger and more precise values. So now what I'm going to do is that I'm going to print the values of all these variables. And to do that, I will use my printf function and I will use format specifiers. The format specifiers simply tell the function which type of value will be printed. So if you're going to print an integer variable, you have to use the %d format specifier. And if you're going to print the value of a character variable, you'll have to use the %c format specifier. And if you're going to print the value of a float variable, you have to use %f. And if you're going to print the value of a double variable, you'll have to use %lf. And then after that, simply write the names of your variables. So since I've written %d first, that means I'm going to write my integer variable, and then I'm going to write my character variable, and then I'm going to write my floating point variable, and then I'm going to write my double variable. So this is it. So now when I run the program, it's going to print the values of these variables, and up to 6 significant figures in case of float and double. So make sure you take care of the order. So if you're trying to print an integer variable first, you have to write %d first. If you're trying to print the character variable second, you have to write %c second. If I change the order, for example, if I write here my floating variable fo, and if I write here low fo, and if I write here, for example, num and ch. So now the format specifiers are not matching the order of the variables. So for example, %d is used for printing integer values, but here I have a floating point variable. Similarly, %c is used to print character values, but here I have a double variable. So the order is not proper. So when I try to run the program like this, it will give me garbage values. It will give me, values that are useless. So take care of the order. And now, okay, one more thing I want to tell you is that do not assign a different value to a different data type. For example, right here, I have an integer variable num. So if I initialize it to the character a instead of an integer, and when I print it using the printf statement and %d and num, so now when I run the program, I'm not going to get the character a in my output. Instead, I'm going to get a value 97. And I should be getting the character a, but since I've assigned this character to an integer variable, that is why I'm not going to get the character a printed in the output screen. Instead, I'm going to get a value 97. And right now, I'm not going to talk about how I'm getting 97. It's just basically that each character in the C language has its own integer code. And that code is called ASCII code, and you can search that up in the ASCII table. So if you're interested, go search on the internet ASCII table, and you'll find that each character has a corresponding integer code. But I'm going to talk about that later on. So just keep in mind that whatever is the type of your variable, only assign the value of the type. So you should only assign integers right here. Similarly, if I try to assign a decimal point number right here, so when I try to run the program, again, I will only get the integer value 1. I will lose my decimal point and the values, the integers after the decimal point. Because this is of type int, it only prints integer values, it only prints whole numbers, it does not print or it does not store decimal point numbers. For that purpose, you have to change the type to float and simply change the format specifier to F right here. And now when you run the program, since the correct value is being stored in the variable of correct data type, then the correct output will be printed in the output screen. So, and one last thing before I end this tutorial is that each data type has its own size. For example, short int, it is also a data type. It is a type of int that can store values from -32,768 to 32,767, and it occupies 2 bytes of space. So if I define a variable num of type short int, and I assign it an integer value that exceeds its range. So its range is up to 32,767, but I'm assigning it 40,000. So now when I try to print the value of the variable using the printf command, and since it is of short int, so its format specifier is HD. Each type has its own format specifier. So when I try to print the value of the variable num, I will get a garbage value in my output screen, because this 40,000 has exceeded the range of the short int data type. So if you change this to int, now the range of the int is I think from -2,147,000,000 to 2,147,000,000. That means it can easily store this integer value right here because it falls in the range of the integer data type. So again, let me change my format specifier, and now when I try to print the value of the variable num, it will give me the correct answer. But if I exceed the range of the data type int, so for example, I write here 4 billion, and a billion has 9 zeros, 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is exceeding the range of the integer data type. So now when I try to run the program, okay, one more thing. Make sure you change the format specifier to U for unsigned int. No, sorry, %d, it's right, because I'm printing a variable of type integer. So when I run the program, it's going to give me a garbage value because 4 billion is exceeding the range of the data type int. So for that purpose, you have to change it to a data type that can actually store this type of value. And for that, I'm going to write unsigned int. So the unsigned int is the same thing as the data type int, but its range is from 0 to 4,100,000,000 something. So it only stores positive integer values. So since 4 billion falls in the range of the unsigned int data type, so when I try to print the value of the variable num, and again change the format specifier to U for unsigned int data type, so now when I try to print the value of the variable num, I will be getting the correct answer. So this is all it about primary data types. If you have any questions, please ask them in the comment section, and thanks for watching this video.